Are we back in the 5th grade? Excellent. How do we find the area of a rectangle? Roman. Length times width. Right? And indeed, that is how we multiply everything. Right? That's why we say something is 3 by 4. Because if I do this... Oh, damn it. I thought it would help. Six red dots. 1, 2, 3, 4, 5, 6. It is trying to communicate, actually. The red light flashing means something. I have to look it up because I can't remember what it actually means. Huh? I don't know, Roy. I was just saying the 6 flashing lights means something, and now I have to look it up to find out what it means. Well, I don't think it's either of those things. I think it's the projector.
How old is that projector?
Not very. Because it gets a new lamp. But like everything, it is built by the lowest bidder, by people who are being paid the littlest amount possible, with materials that have been procured by people being paid the smallest amount possible. As a result, quality is significantly lessened in current products.
By the fact that it's not using HDMI port, it's really bad.
Why?
Because
Regardless of whether it was HDMI or not, that would not affect whether it was turning off or on. Anyways, as I was saying, it'll wake up. So, as I was saying, this would be 2 by 4, which would give us 8. Right? Excellent. Now, so area equals LW. Now, what if it is that very special rectangle that gets its own name, a square? Is a square still a rectangle? Yes, indeed. So we could still do area equals LW. But of course, in a square, LW, L equals W. So we don't write LW because they're the same value. We use different letters when the values are different. So rather than write LW, we can give it the same letter. I'm going to say it is S. So the area of a square is L times W, but L and W are the same thing, so the area of a square is really S times S, which is, of course, S squared. What? Abbotsford Senior Secondary. What the hell are you talking about, Gideon? Get your mind out of the gutter.
School. That's so funny, because that's the name of our school.
I know, right? Absolutely.
Abbotsford Senior Secondary School Square.
Okay, so you're intelligent young people. If the area equals S squared, then the side must equal the square root of the area. That is where the term comes from. That is why we say square root. It's also how we get the symbol for vans. But that's beside the point.
It's the square root of answer.
It is the square root of answer. That's why the symbol is van, is that. It's the square root of the answer. Anyways, square root of A. This symbol is asking you to find 2 equal factors of, now this is key. Prior to right now, the only thing that you have seen written this way, that I can guarantee you've seen written this way, is that symbol and some number there, right?
Yes.
Okay. In the real world of math, it is not necessarily going to be a number there. So we need to find two equal factors of the expression. Now remember, an expression is anything mathy. Of the expression that is under the sign. Now, we need to talk about a few of these things. The name of the expression that is under the sign. It gets a special name. I will be using it on a regular basis, so you will need to know what that word is. So when I say it, you don't go, what? It is the radicand. Please learn the word.
Are you a radican or a radican?
The other thing you need to know about that symbol is it is not a square root sign. I know it just turned out. It is the radical sign, spelt like the 1980s word for cool stuff. Radical. All right?
Mr. Myers, I can't ratty can't wrap my head around it. I'm sorry.
Get it? Because the word is radican and radican.
Yes, Gideon, you got it.
Actually, I'm going to actually for you. We're going to use it for light. Time travel.
So, how do we find the volume of a prism? You can read the next thing on there. Nobody knows how to find the volume of a prism? Roman. Absolutely correct. Length times width times height. L, W, H. It'll come up. That's a prism. What if it's the very special kind of prism that we call a cube? What do we know about L, W, and H?
Then they're all the same.
L equals W, L equals H, W equals H, L equals H, L equals H. So what do we write instead of LWH? S times S times S, which is S cubed. Now you're intelligent young people. If the volume equals S cubed, then the S must equal the cube root of the volume. Now please notice the radical sign has changed. Not very radically. Just a little bit. What is the change in the radical sign between when we first introduced it to now? There's what looks like an exponent, yes? Because it's a little 3 and it's written above the line. So the first thing we're going to do is talk about this. This asked me to find two equal factors. What is this asking me? Excellent. To find three equal factors of what? The radicand. Thank you. All right. Now, this small 3 is called the index number. Please highlight it. And as Mia wisely, what's the word I'm looking for? Surmised, it is related to exponents. The index number, and I know it's blank, you're just going to have to listen to what I have to say. The index number tells you the size of the group of factors that you are seeking. Okay? So, the index number tells us that. Now, the next line says a perfect square or perfect cube is. Now, if I say, what's a perfect square? Somebody in the room is going to say 4. If I say, what's a perfect cube? Somebody in the room is going to say 8. All right? And that's okay. For the most part, that's what we mean. But a better definition is a perfect square or perfect cube is any, and I'm going to highlight that, and you should be writing, I'll speak slowly, any expression which yields a rational root. So, when the screen comes back up, you'll see some examples of this. The square root of 4 is 2. 2 is rational, therefore 4 is a perfect square. Everybody cool? The cubed root of 8 is what? 2. Because 2 is rational, therefore it is a perfect square. For our intents and purposes, this is what I mean by perfect squares. But I need you to be aware of something like this. Does that have a perfect square? Or a root, I mean.
Yes.
Yes. What is it? Now, we just worked on converting those into fractions. So that is 144 over 100. What is the square root of 144? Over what is the square root of 10? 10. And that is 1.2. So, is that also a perfect square? Yes. But for our purposes, we are going to stick to whole number perfect squares. Everybody cool? Because that's what we use the most of. All right? Now, Roy just asked a very good question. Is 0 a perfect square? Some people will argue yes, because 0 times 0 is 0. So what is the square root of 0? 0. But how do we find square root? 2 by 2, right? How do you make a square that is 0? You can't, right? So I will leave it to you to tell me why or why not is 0 a perfect square. Go and learn something later, not now. Now learn this. Turn the page over. Remember how I said all the math you've ever known has been absolutely key? Higher level math relies so heavily on squaring and cubing that it is akin to how important add, subtract, multiply, and divide have been up until now. Do you understand what I am saying? Good. So we are going to list the perfect squares from 0 to 400. And of course we mean natural squares, right? We're not going to start with 0. We're going to start with 1. We're going to put the squares there and the roots below them, because roots go below things. What is the square root of 1? 1. Now, right now it's real easy, because you all know the next perfect square is what? 4. 2. But pretty soon you're going to run out of knowing these perfect squares. But you're always going to know the next root, right? What is the next root? So what is its square? 9. And keep going until you have a 400 up there. And of course you stop at 20. I cannot stress this enough, ladies and gentlemen. You won't believe me, but at some point in the near future, you will be sitting there and saying, damn, this would be easy if I could do this in my head. And I will be in your head going, wah, I told you so.
While it's doing that, can I go complex rate?
So, I want to call your mind to a couple of patterns here. 1, you will notice, what is the numerical distance between the first 2 perfect squares? 3. What is the numerical distance between the second 2 perfect squares? And between the third 2? And between the fourth 2? It's 8. That subtraction's a bear. So it is going up by what? Every odd number, yes? So what is the next perfect square that we don't have written down on the sheet? The next one, what is 21 squared? You didn't write it down. I'm asking you, now that you've seen the pattern, tell me what 21 squared is without touching a calculator. What is it?
21.
Yes. 441. Why? Well, because here I added 39, yes? And I'm going up by odd numbers. So here I would add 41. What will the next one be? 43. So that will be 484. And that would be 22. And so on, and so on, and so on. That is the first pattern I would like you to see. The second pattern I would like you to see is, let's make a comparison here. The square root of 100 equals 10, yes? Everyone agrees? Okay. The square root of 400 equals 20, yes? Okay. The square root of 4 times 100, what is the square root of 4? 2. What is the square root of 100? What is 2 times 10? 20. Does everybody see that handy little pattern? I'll give you another example. The square root of 36 is what? 6. Everyone agree? But it is also the square root of 9 times 4, yes? What is the square root of 9? What is the square root of 4? What is 2 times 3? Does everybody see the relationship? these radicands can be broken down into smaller radicands, and then you can use that to work on bigger radicands. Everybody understand? So, here is what I mean. Yes, Ethan.
Would the square root of 900 be
30, yes. That's
it just keeps, like, the hundreds are just the base numbers.
Yep. Everybody cool? So, Ethan just asked what I was going to show you. So, if I wanted the square root of 900, you would say, oh, well, that's 9 times 100, which is 3 times 10, which is 30. Right? Now, it works nicely with hundreds, as Ethan pointed out, but it also works with everything else. For example, 64 times 4 is 256. The square root of 64 is? The square root of 4 is? 8 times 2 is? 16. What's the square root of 256? 16. Everybody cool? It is a very powerful little piece of number theory, and it will come back to help us tomorrow. Okay? So, now let us do the cubes. They are a little more difficult, of course. 1, that's an easy one. 2 cubed? 8. 3 cubed? 27. 4 cubed? 64. 5 cubed? 125. 6 cubed? 216. 7 cubed? 343. 8 cubed? 512. 9 cubed? 729. And 10 cubed? 1,000. And I know the screen went down.
Is there any pattern in this one as well?
Do you see one? I went up by 7. I went up by 19. I went up by 40, 33. I'm sure there is. I've just never bothered to find it. I've just memorized the first 10. Boop. Now, all of you cast your mind back to your grade 4, grade 5 math textbook. It was probably jump math or math makes sense or something like that. And remember back when the very first question of the very page you were working on, number 1, had instructions. And the instructions on the first question were always estimate. Do you remember that? And you immediately threw away the textbook, picked up your calculator, and punched in what was actually written there, yes? Yes, you did, Shayla. You're a liar. None of you estimated ever because you knew you wanted to find the right answer. And Mrs. Bad Crumble would let you get away with that horse crap because you were cute little kids and she didn't really care if you didn't follow her instructions. Now, when your math problems are 15 to 16 calculations long instead of 1, you immediately do not do what Mrs. Bad Crumble taught you to do and estimate. You grab your calculator and start mashing on it like King Kong. You then hit equals at the end of what you think are the appropriate calculations. Your calculator gives you an answer, and you immediately write it down because your calculator said so, and it can't possibly be wrong. Except, of course, you don't really know how to use your calculators because you don't really know how to do math. So, what we are going to do is you are actually going to do some estimation now. You are not going to touch your calculators for the rest of page 34. Even though you see square root of 72 and you're all getting twitchy, You all want to hit that square root and the 72 button. Ethan is hiding it behind his binder and finding square roots as we speak. No, it was...
I physically can't.
It was just for comedy, Ethan. Relax. Relax.
Yes, that's
All right? Now, let us show you how to do this. Is the square root of... Now, in grade 5, you grab your calculator, you go bloop, 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 and you get an answer and you write it down. Right? And in grade 5, that was the end of the work, wasn't it? You wrote down the decimal, you rounded it off to the nearest decimal place, and Mrs. Bad Crumble gave you a gold star, and then you walked away, right? Okay. We don't do that in the 10th grade because that is maybe half of the first step. So before we go to our calculator on a 15 calculation question, we will always estimate so we have an idea of what the answer is. So when our calculator spews out gobbledygook, we can say, damn, son, I know that's not right. Okay? Okay. So let's look at 72. Is 72 a perfect square? Of course not. It's not on our list. But it resides between 64 and 81, does it not? Which means the square root of 72 must reside between 8 and 9. Must it not? And isn't 72 approximately halfway between 64 and 81? So isn't the square root of 72 approximately halfway between 8 and 9? Which would be 8.5. And if you punch that into your calculator, you indeed get 8.48 blah. Okay? Everybody understand? Let's look at the next one. Is 180 on our list? No, of course not. It resides between 169, which is 13, and 196, which is 14. Now, if we're just estimating, we could look at that and say, well, 180 is a little closer to 169 than it is to 190, yeah? And it's right around the middle, yeah? So we could guess what? 13.4? Which is perfectly acceptable. Now, of course, I will allow you to get a slight degree more accuracy here. How far is it from 169 to 180? 11 steps. How far is it from 169 to 196? 27 steps, yes? So I took 11 numerical steps out of a possible 27. Right? Which is 11/27, slightly less than half. So 13.4 was a wonderful guess. Everybody good? Great. What's 300? What's it between? 17, which is 289, and 18, which is 324, right? Well, it's 11 steps past 289, right? And it is from 289 to 324 is 35, yes? Is that pretty darn close to 11 over 33? Which is pretty darn close to a third, isn't it? So would 17.3 be a good guess? Certainly it would. Does anything change with the cubes? No, of course not, except the gaps are bigger, right? 45 is between what and what? 3 and 4, 27 and 64, yes? Is 45 closer to 27 or to 64? Or is it right about the middle? Right about the middle, so 3.5. 405 is between what and what? 7 is 343, and 8 is 512. 405. Is it in the middle? It's more like a third, yeah? 7.3. I know it's black. Do 176. It's, of course, between what? 5 and 6. 125 and 216. Right? So 50 steps out of 90 steps. Slightly more than half. So what would be a good guess? 5.6. Sure. Everybody good? All right. Now, I'm actually done the lesson now because I want you very comfortable with monkeying around with roots before we actually get into them. Because this year, and maybe you did it last year, but this year you are going to learn what to do with that. And it is what you will do with that for the rest of your math life. Because it is never, I shouldn't say never, it is often not 8.48 blah after today. Everybody cool? All right, so turn the page over. You're going to do two different things on these next two pages. On page 35, without a calculator, you are going to attempt to tell me the square roots. I shouldn't say the roots. The radicals on this page. Oh, they are all square roots, so that's cool. You're going to attempt to tell me all of these square roots. If it is rational, this is a perfect square, you give me what you think the square root is. You are on your honor, use your brains. If it is irrational, I want your best estimate as to what it could be. Does everybody understand? All right? Ethan.
With the negative 196 on page 35, how do we get that? Because if we take a negative number and times it by itself,
I think you know something about negatives and radicals and negatives and exponents, don't you? Is this, Ethan, is this the same as this? Apply that knowledge to this and see what happens. On the next page, page 36, all I want to see on 36 is what the square root is or an estimate for it, again, without calculators. Now, you will notice on page 36, there's some big old numbers there, aren't there? But hasn't your favorite teacher given you some ideas of how roots work and what you can do with numbers bigger than what you know? Yes, he has. So go.
Why would a computer science teacher do that?
Very funny, Gideon. I'll give you another joke, too. I love it when my favorite students tell me jokes like that. Thanks, Ethan. See what I did there?
Which one though?
Doesn't matter, Gideon. The point was, it wasn't your name. All right.